Well, thank you very much. It is an honor to be here, honor to be at part of the Illinois Consortium, and as you guys are soon to launch at UIC and Northwestern, and I believe Rush already recently having launched. We echo all the things that you've been seeing, and the whole challenge of recruiting a diverse population is exactly one of the reasons why this program exists. So I'm going to talk through a little bit about the setting of all of us, and some of these slides will be a little bit duplicative, and we'll just go through them quickly. But I want to start with a core problem here, which is, how do we predict the sort of different disease risk? How do we predict the different medication drug response? And this was something Dr. Nguyen highlighted, that we all know we have variable responses, we have variable disease risk and variable disease courses. And it's really the challenge of using different sorts of data across those kinds of things to predict it. I'm going to talk about one sort of genre and then jump into all of us as how we think we can extend that through that. And I first want to start by looking in the past, because if you turn back the clock to before 1948, before the Framingham Heart Study and many studies such as this, we didn't really know the importance of exercise, of not smoking, of cholesterol, blood pressure on outcomes. And it was studies such as these that really started to show the effect of those kinds of exposures that we all take for granted as being important for health. And you can see that curve there from this 1961 publication. It was not abnormal, and it was not necessarily considered bad to have a cholesterol of 300, to have a systolic blood pressure of 175. And you can even go back to our Franklin Delano Roosevelt and watch his physician recording his blood pressures in excess of 200 before his stroke without understanding the causative relationship there. And so what can we do, and how can we extend this, and where will all of us play that next part? If you look at the change in cardiovascular mortality here from the CDC, you can see that there's been a dramatic fall that really corresponds to a lot of those intervenable risk factors that were identified through cohorts such as Framingham. And if you think about the genetic studies, so there's been a huge explosion since 2003 when we had the first draft of the Human Genome Project in terms of genetic discoveries. And this is just for common disease. This doesn't even include the 6,000 plus Mendelian diseases that we have a remarkably increased understanding of. That with these 3,000 or more genome-wide association studies, I've found more than 52,000 pairs between variation and genomic traits and their phenotypes. And each color here represents a different phenotype. Interestingly, when you look at hundreds of phenotypes that have been explored, they only 7% of them map onto drug response traits. And when we looked at an EHR of about 1,600 phenotypes that we defined, only 86 of them had been studied by GWAS before. So even though we've done a lot and we've discovered a lot, there's still a lot left to discover, and a lot of that is clinical. This is an example from looking at our own biobank at Vanderbilt. So we started collecting samples in 2007, and we have about 250,000 individuals now. What I want to really point out here, though, are all those blue dots. So by the first people were enrolled in 2007, but you can see that we have data on individuals dating back to the 1980s. And so you have this ability to go in silico back a long way on individuals and really get a longitudinal exposure and do things prospectively in silico in addition to what you can do looking forward. And so I'm going to give you just a few examples of discovery using electronic health records. The first is I'm going to talk about is autoimmune hypothyroidism. So we're part of a network that at the time had 5 sites called the Electronic Medical Records in Genomics, or eMERGE network. And those 5 sites were part of it. And we each genotyped 2,000 to 3,000 individuals for different reasons. So at Vanderbilt, we looked at cardiac conduction. At Group Health in Seattle, they looked at dementia. And then what we said is we all were exploring our own things. What if we put all these samples together? And what if we looked at a new phenotype that none of us explored, and looked at those look at that phenotype, that disease within those the already genotype populations using the electronic health record. And that algorithm was for autoimmune hypothyroidism, and we developed the algorithm at one site, we exported it and deployed it at the other 4 sites, and you can see the positive predictive value, or PPV, there for cases and controls were both very good. It was a little bit maybe lower performance at Mayo, and that was because the records, they had more people that didn't get primary care there, so we couldn't tell whether it was due to surgical causes versus autoimmune causes. And then we discovered a new thyroid transcription factor that was associated with autoimmune hypothyroidism, and it was replicated in other studies. So extending this to other kinds of things, when you have electronic health record, I gave you one example of looking at a new phenotype. You can look broadly across many different phenotypes, and so we came up with this idea of looking at a phenome-wide association study and looking across many different diseases. This is looking at a number of conditions that had known associations, and so each point along a row represents that one single nucleotide polymorphism that's associated with that disease. Everything to the right of that faint blue line is a significant association. Overall, you can see that we replicate using the EHR, and this is actually a fairly crude, efficient method of doing it, many different associations across many different disease classes. Overall, we replicated 66% of those things that we were 80% powered to detect a signal for. And importantly, when you looked at a population, 90% of people participate in more than one study. So and it's no surprise that people have multiple exposures, multiple diseases over time. Here's another example of one of these things. So this is looking at the HLA region of the genome, which is one of the most pleiotropic regions of our genome and is influencing many different diseases. And you can see that here. And so with a very small population, when you think about something like all of us, 37,000 individuals, we're able to see a number of different associations. Some of these were new. And it just starts to hearken on the kinds of genomic studies we can do with all of us, and obviously detail much more. What's especially interesting about this kind of studies, you can actually look at the co-occurrence of disease within a single population because it's the same individuals being studied for all these different diseases. And I'll give another example. So we think that pharmacogenetics might be an early implementation opportunity for a lot of genomic traits and thinking about drug response. And so one example of this is looking at the drug clopidogrel given after someone has a heart attack and receives a stent, as well as some other use cases. It is a prodrug, so what you take is an active. It's activated by CYP2C19 primarily, which converts it to its active form. And so people that have copies of CYP2C19 that are inactive don't convert and make as much of the active form. And in this case, you can see those individuals have about a 50% increased risk of having heart attacks or other major adverse cardiovascular events. And this has been seen in many different contexts. This particular one is using the EHR. And then implementing that through decision support in the EHR, as we have done in others, can actually improve outcomes. So people will respond to their genetic variants and prescribe alternative therapies. And you can see, if you pull that all up, the people that get prescribed alternative therapies in that bottom, does this have a laser on it? It's what? Aha, great. You can see in the bottom here that these are the people that have the loss of function variants, and they have a higher event rate here. And if you switch their therapy, the event rate drops dramatically. And these are the people that are in clopidogrel that don't have a loss of function variant. These were not statistically significant, though. With a larger population, they may have been. But this is statistically significant. Ideally, we get all these individuals swapped, but there's a number of reasons why they may not. Some of that is cost, but we see a change in outcomes, which I think is a positive. So now switching to the All of Us research program, Dr. Nguyen pointed out nicely about the bipartisan support, and this is actually from the moment in which President Obama announced it. And I like to point out that everyone is standing here. And so it really dramatically shows that it does have strong support. And indeed, in addition to the funding that's been provided from Congress on an ongoing basis, the 21st Century Cures Act was passed, for instance, in the Senate 94-5, and it presents about $1.5 billion over the next 10 years, in addition to that regular funding for the All of Us research program. So we are showing continued support from Congress in both sides. So some of the goals for us, and really this has been covered nicely, the relationship aspect of this and engaging our participants is a huge part of this. This is an ongoing project that will last many decades. This is not a one-off research study. We're building a platform that will be a huge biomedical data set, perhaps the largest that's been created, and it'll be accessible by a community. And we want to create that ecosystem that really is longitudinal, that participants want to interact with us, that researchers want to interact with us, and that it grows as a community. The basic outline, I think, has been echoed already, at least 1 million individuals, a longitudinal recontactable component of this, some of the basic data points or EHR data, biospecimens, baseline evaluations, and the initial network, as mentioned, was formed in July 2016. Diversity is a huge part of this. And we have a goal of representing the underrepresented populations and traditionally in biomedical research at least 50% of our target. So far, we're actually about at that number. We're just currently in our beta phase, and we're actually not even trying to focus on that. We're trying to work out the kinks in the system. You can see where we are in terms of genetic research by this slide. We've gotten a little bit better in 2016 from 2009, but you can see the vast majority of genetic research so far has still been done on those of European ancestry. And if you look at these, these percentages here, this 4% of the current GWASs represent about 33% of the U.S. population as you look forward in the coming decades. And so, we really have an imperative to increase that representation. And it's also really important for us, for all of us, that we do study all of us, because we'll miscall and misthink variants are pathogenic or benign when in fact they may be the opposite may be true. And studying all of us helps us figure that out. This has already been presented, the different recruitment sites and different components. I represent the Data and Research Center at Vanderbilt. We have one biobank at Mayo. They do replicate their samples from Rochester down to Florida in a component. So we're going to take many kinds of data here. So, people often think of genomics. We'll have health surveys. We have a couple of those launched. We're creating more. Health records are part of this. The smartphone kinds of technologies and geolocation are an important part. Linking with other kinds of resources. Wearables will be part of this as well. And actually, the Fitbit, a partnership with Fitbit was just announced, I think on Tuesday, for piloting Fitbit in about 10,000 individuals. And we expect to pull in other kinds of data like imaging data over time. The real power of this, of course, comes from integrating these data, and that requires the participants to give you the data and partner with you and help you link it, as well as technology and researchers as they generating data, giving that back to us as a common resource. The ports of this, these two pathways, traditional research studies have really leveraged academic medical centers. The growth of the healthcare provider organizations here, incorporating FQHCs as well as academic healthcare centers, and then distributing them across the country, and then partnering also through people that are not part of maybe linked into an HPO through direct volunteer mechanism really gives us a lot of power to recruit across the entire country. And then we intend to have the same data set essentially in everyone. So after the consent process, the health surveys will be completed, and the baseline measures, which are a limited number of items right now. It's height, weight, hip, waist circumference, and pulse and blood pressure. Biospecimens are blood and urine currently, and if for some reason you can't give blood, we collect saliva, and then smartphone and other kinds of wearables over time. I like showing this slide just to show the number of partners we have. It's very diverse and broad. The top row are those that will help recruit direct volunteers. So we have dense U.S. coverage through places like Walgreens and Quest, really allowing us to, individuals hopefully to have places near them to enter into this program. And of course, you can see the Illinois Precision Medicine Consortium there in the second row, and your sites there. Is an important component in a large geographic and population area that's quite diverse. Coming after this, Dr. Watson will talk about some of the engagement efforts, so I'm not going to talk deeply about this. I'll just say before all this began, we engaged in a number of community engagement studios across the country, in a number of different cities, and targeted 16 different populations, not just your typical diversity metrics, but also things like hearing impaired, visually impaired, multiple chronic diseases, those who don't have access to the internet, to help us inform this, including those in Chicago. I already mentioned the physical measures here and the biospecimens we're collecting. An important part of this is also giving the data back, and so we start that at the initial visit. And so when you go through your first visit, you get a card that looks something like this, where you can get your, they tell you what we have so far, which is not much, but it is, we're giving back your blood pressures and pulses. And if they're above certain ranges, of course, we trigger certain advice based on that as well. And those kinds of things will be available through the portal as well. So health surveys are an important part of this and have been a foundation for many studies before this, and it's part of ours too. We want to be smarter about the questions we ask, thinking that we expect to get information from a number of different resources, such as the electronic health record. So we took all those and about 20 different resources, sorted through those. It's a multidisciplinary team looking through and pulling together what our health surveys look like. And then we tested them with diverse populations across the country through a couple different perspectives, both cognitive interviewing for English and Spanish, and then also computational testing, where we had diverse populations take it. We looked at how long it took. We allowed them to annotate questions that were difficult to understand, or maybe offensive, they thought needed different options, and then we incorporated that into the questions and have agreed upon metrics. We're also taking these questions and mapping them to other kinds of data sources, such as electronic health record standards. So we'll be able to line those two data sets up, and you'll be able to compare them and look at where the information agrees and where it doesn't, and that will help us get smarter as well. And these tells you what we have released currently. We have a baseline demographics survey called the Basics, something on lifestyle, which gets at habits and activity and overall health. Collectively, these are, we're going for short surveys that you can, in multiple ones, you can take through and you can monitor your progress. You can start and stop through the way, currently through the website, and then there's also a smartphone app that will be coming out soon for both Android and iPhone. And we have a number of other ones in development as well. At the Data and Research Center, our job is to manage, protect the data, and make it accessible for researchers. We have built tools as infrastructure, so there's a common series of websites, authentication process, portals of entry for all the researchers that are inputting data in these diverse collection sites, because at the end of the day, there may end up being thousands of individual locations where someone may walk in, and we want to make sure that all those individuals interacting with the system have a common experience, and we ensure data quality and keep the data secure as it comes in. They can, it was discussed about keeping the information secure, and we've met federal security standards for that and really focused on how we maintain that and protect it. This shows a little bit about what our data paradigm is, and an important aspect is everything comes into what we call a raw data repository, and over time we curate it, and this curated data repository, which has obvious identifiers removed, is the source for doing research. And then we interact with the participant portal, where the websites and things that the other sites use, and then also link into other centrally linked kind of data that we can pull in, and are the linkage to the biobank. So one of the things is, how do we get information from individuals who aren't connected to a healthcare provider organization? So we've been working with the Office of the National Coordinator and creating standards that allow us to pull data in using patient portals and allow an individual to go from a research app to a patient portal and authorize sharing of that EHR information through common standards, common handshake protocols, and data formats. And so this is the kind of thing, if it succeeds and works and it's actually part of meaningful use stage 3, means that we could actually mobilize healthcare data for clinical uses as well eventually, which has a application for many beyond 1 million individuals. We're starting a pilot in 14 different sites. You can see that here. I mentioned the idea of curating these data, and so all these data will be coming in, and it's going to be the kind of thing that will get smarter over time. So we'll have releases maybe a couple times a year on the curated data repository. Those will have version numbers. They'll have protocols around how we've made them. I'm showing a picture here showing kind of the current model that Google uses to take data and curate it. And so when you do an image search in Google, it's interpreting what your image looks like using deep learning, and as was talked about earlier. And so those kinds of new web-based techniques we expect to perform over time in our data too. An important aspect was individuals get access to their data. This is novel, certainly, even for small studies. It's certainly novel on a study where, at the scale where people may not be connected to an electronic health record. There's certain challenges with that. If you think about genetic data, individuals that have sequence data will be diagnosed with clinical conditions they didn't know they had. To guide us here, there's a study that was done in Geisinger, about 50,000 individuals, and in that, they found that those individuals, about 3.5% of them, this bottom right grid here, had a genetic condition that was diagnosed through the sequencing results. So a small number, but amongst them, only 14% of those people were actually known to have the condition. So this is things like risk for breast cancer, colon cancer, that you can do something about. So that's a real potential health impact of the study. In addition, I mentioned pharmacogenetics earlier. This is an area that will affect many more people. So in red and blue are people that have actionable variants. And when you look at those across just 5 drug-gene interactions that we know about, 91% of people would have an actionable variant that you would do something different for. So we would be returning this and making it potentially commonplace for healthcare systems to think about being actionable on these data. Dr. Nguyen showed this earlier, and so the key point here is we're centralizing the data, thus hopefully democratizing its access and making it more available, faster to get access for a much broader population. And so we're going to have different tiers here. We're going to have public data, but that's going to be aggregated data, and that will include pre-computed results as well. So that will be useful to people doing studies and investigating hypotheses. But then the individual data will be on 2 different levels. Right now, the draft has suggested what we call registered controlled data that is progressively rich data. All this will have an obvious identifiers, name, address, social security numbers, that kind of thing, removed from the data, and will make it accessible to individuals. And the protocol for doing so to make sure that we have a degree of trust will be a process whereby the individuals sign a code of conduct, we know who they are, the researchers coming in, and then an approval process. And when you want to get access to the control data on the far right, there will be a loop through an institution. Right now that's through an ERA Commons ID, but we're going to look at other methods as well. And then as part of mandated by the 21st Century Cures Act, you will have to create and express a purpose for why you're doing research, and that will be public. So the researchers, it'll be easy on for access for researchers and automated much of this process, but then participants will also get to know what kind of research is being done with their data and what results come of this as well as part of our contract. We intend to make data, many routes into the data, and try to make the predictable, easy, expected kinds of research as simple as possible to do through web-based interfaces. This is a screenshot from a mock-up from tools that we use at Vanderbilt to define cohorts, where you can look at individual records and individual charts, and you can annotate those charts and create criteria to find a population of interest. And then you can export it to a computational environment here, and in this computational environment, you could do different kinds of algorithms and run that on top of those data and do your genome-wide association studies, look at your environmental influences, and produce your results. This is an example of some web-based tools we are developing across the Data and Research Center to show pre-computer results. So this is a GWAS on actinic keratosis. You can click on a variant and see a PheWAS on that variant. And so this will support large-scale data and allow people to browse pre-computer results without having to go through the access process. So as was mentioned a couple times now, we are recruiting in a beta phase right now. We're deliberately being slow as we develop and test protocols and refine things. We are actively refining a number of elements now and bringing, for instance, the Spanish language translations out. We don't have those quite yet. We have them. We haven't fully tested them, I should say. And then that includes a number of sites. Where we are now is the initial IRB approval and FSMA certifications and all that penetration testing on the computational backends. We have currently 14 sites that are going. It includes 7 HPOs, 6 FQHCs, and 1 direct volunteer site. So all the components are doing something at this point. We currently have about, actually it's 5,700 today. It was 5,600 yesterday. In this picture, that picture of the samples there were the first biospecimen samples coming in. You can see over there, and I think that's all blood right there. The bottom is the mobile engagement center, which goes around the country, and individuals can come through that and experience and learn about the program and then sign up. This is a little more of a timeline, so you can see where we are now in the middle. As you go through, we expect we're entering an expanded beta phase where we will scale up to 10,000 to 15,000 individuals and test and revise the protocol, as I mentioned, work through these things en route to a national launch targeting the spring of 2018. Over the next 4 to 5 years, seeking to enroll those 1 million participants and continuing for many decades. And I'm going to just give 2 small stories of real people that are real examples of personalized and precision medicine that have benefited from this. So this is an individual that presented at Vanderbilt, 57-year-old. At first time she had heart disease, has some family history and high cholesterol, and she has a myocardial infarction, receives typical care, started on clopidogrel, and this is state of the art, and this is completely appropriate. But she comes in and that stent closes off, and it comes in again and it closes off again, and she gets restented. The doctors talk about continuing Plavix or clopidogrel and aspirin in their notes. That closes off. It closes off, and 11 months later, she's had 9 admissions and 5 catheterizations at which 9 stents were placed. And the genotyping reveals she's a poor metabolizer. She has switched to an alternative agent, and she then doesn't have another ACS event for at least the year or so after that. So a dramatic change in care, and obviously you want to genotype and you want to do that the first time, you want to get it right. And you can argue that clinically maybe they should have done something different anyway, but the fact is that many people don't because it is seemed to be random, but randomness is not always random. And we can predict that through looking at genetics, looking at social factors, looking at exposures. Here's another example. So now for a rare disease. So I have cystic fibrosis in my family as well, and 4 aunts and uncles that died of CF at a young age. Typical care of CF has improved life expectancy dramatically from the less than 8-year-olds in my family through to 3rd to 4th decade. So, but recently we've seen very targeted therapies that are dramatically changing events. And so this is the brother-in-law of someone in my lab who has cystic fibrosis, and he is seen with some of these targeted therapies. He actually has improvement of lung function. And so you can see this recent picture of him, cutting wood with his kids. And that's something he couldn't have done 2 years ago. But with these targeted therapies that have now been discovered, he is experiencing a quality of life that he hasn't had for a long time. And so this is their data and research center here, a number of individuals here across our different sites, and that's in New York. It's Nashville certainly doesn't have that many skyscrapers. And then this is all of us from the initial awardees in July, and I see some, so I think Kareem, I think you're back here. And Phil Greenland's in here somewhere. I don't know, Rob, I don't know if you're in this picture, but here's Phil Greenland from Northwestern. And at the kickoff of this event, which is, we see as the next Human Genome Project, but really bringing it home. This is a dramatic next stage. So with that, I'll thank, I think we move on to Kareem.